India is ready to conduct one of the most ambitious experiments in space, a space docking, undocking experiment using two Indian satellites and with indigenous technology. Only four countries have are doing this. Only three countries have done this earlier, and India will be the fourth country. It is a complex technology. I have with me Dr. Sankaran, the director of the UR Rao Satellite Center in Bengaluru, the place where these satellites were tested and the place where these two space docking satellites were conceived. Thanks a lot for speaking to me, Dr. Sankaran. Always a pleasure talking to you. Why are we doing this space docking experiment?
Because this is an enabling technology for many missions, particularly for ISRO. Not only for ISRO, for everybody. If you want to have human space flight and a sustained presence of humans in space, you require docking technology to carry and transfer crew to the space station, and similarly carry and transfer cargo to the space station. Similarly, if you want to go to Moon or Mars, docking is essential. Without that, with a crewed flight to Moon or Mars is not possible. It is essential. That is why, for everybody, all spacefaring nations, SpaDeX kind of mission where docking technology is evolved is important. But even more important for ISRO is because if you recollect when the Apollo missions were carried out by the Americans, they built a huge rocket called Saturn V, which has Saturn V. Yes, the Saturn V had a capacity of 150 tons to the low Earth orbit. That rocket was particularly realized for the human flight to Moon. And after the moon flights are over, that rocket was retired. It had no other job because it is too big for any other work. So, if you can recollect now, NGLV got approved for 8,420 crores.
Yes.
A satellite launch vehicle which will carry, say, possibly about a fraction less than 50% of that Saturn V capacity. You can imagine how much money needs to be spent if we have to develop a satellite launch vehicle like the Saturn V, not even counting the difficulties in manufacturing such massive structures. In India, we don't have such manufacturing capabilities also, but we do have the ambition to go to Moon with the crew. So how do we do this? We cannot spend tens of thousand crore developing a rocket which is useless for anything else. So we are coming out with a strategy where we will use a moderately powerful rocket and use the docking technology to assemble the craft in space so that the craft that has to go to the Moon will be similar to any other crewed flight to Moon or Mars, but we will be using smaller launch vehicle, do 2 or 3 launches to dock them in space to allow this crewed flight to the Moon possible. That is why it is even more important for ISRO and India that we develop this docking technology for our future.
Essentially, when you have limited resources, how best to deploy your limited resources to get maximum bang for the buck. That is why docking is essential for us.
I beg to disagree on that. It is not that ISRO or India has a limitation in the resources, but we are mindful of on what we are spending the resources. In the money that we need to spend on building a rocket like Saturn V or the Starship, we can build hundreds of other application satellites which will provide essential service to the nation. So it is a priority that we are talking about. India has the required infrastructure and the government is approving whatever we are asking for. So if you had gone to the government with a proposal for a launch vehicle which is similar to Saturn V, I'm sure the government would have approved it. But we are mindful that the rocket is not useful for anything other than crewed flight to Moon or Mars. That is why this approach is required.
How difficult is docking in space?
The docking, when it was done for the first time, it was very difficult, unimaginable. But people have done it in the past, but nobody publishes what they have done. How it was done, nobody publishes. So when we do it now also, it is as difficult or as complex as it was done for the first time in the late 60s. To give you a perspective, a satellite in an orbit, say around 500-kilometer altitude orbit, is going to have a velocity close to 8 kilometers per second. We are imagining we are going to couple an engine to a bogie while both of them are running at that speed, 8 kilometers per second.
Wow.
That is what is going to be done in docking. So it is complex, but it is doable, and we hope we'll be able to do it in the next couple of weeks.
I believe you're using an Indian docking system which has been patented by ISRO to complete this mission. Is that correct, sir?
Yes.
Can you tell me more about that?
See, there is a international docking standard used in the International Space Station, and it is taken as a de facto standard by everybody. And anybody who wants to go and dock to the International Space Station has to adhere to that standard. But when we wanted to develop this technology, we have to restrict ourselves to do this with two small satellites whose weight is going to be around 200 kilograms. So it is not possible to include the international docking standard kind of docking system, because that docking system itself is going to weigh about 400 kilograms. So we had to come up with a novel way of implementing this. So what we did, we first reduced the size of the docking ring. The international standard ring has a clear 800 millimeters diameter in the center for crew and cargo to be transferred. So we reduced that to 450 millimeters, because in our mission we are not actually going to transfer any crew or cargo. It is going to be only the docking. So the size was reduced from 800 millimeters to 450. And in the international docking system, there are 24 motors doing the extension, rigidization, and the retraction function, which we are achieving with only two motors in our docking. Yes, two motors. So it is a miniature version of the international docking standard, but the engineering and implementation has been done ingeniously with minimum resources so that the functional requirements are met. It is going to, once docked, nobody will be able to make out it is any different from the IDSS. It is going to have functionally the same characteristic as the international docking standard system.
I believe this time the satellites which are going to be used for docking, the chaser and the other satellite, were actually made at a private facility, Ananta Technologies. How does that give us benefit, and how does that benefit India?
What was done was we realized all the elements that go into these two satellites at your satellite center, of course supported by other centers of ISRO, and the integration and testing of the satellite, instead of being carried out in our clean rooms at URSC or at iSite, we decided that this time we will get this done at an industry premises. So we went through an expression of interest, called for interest from all potential industry partners who has the necessary infrastructure and the required manpower to do this. And finally, we ended up with having a contract with Messrs. Anand Technologies, who have a facility established in Bangalore, near the Bangalore airport. So all our hardware, subsystems, assemblies were transferred from URSC to Anand Technologies premises, where their technicians and engineers assembled and tested these satellites under the supervision of URSC engineers for both integration and testing. This, after the initial integration, the satellites, both satellites were brought back to URSC, where the environmental tests like thermal vacuum testing, vibration testing, all these were carried out. As a director of URSC, for me, this work is as important as the docking itself, because you know the ISRO staff strength has remained more or less stagnant for almost last 40 years. But the volume of work ISRO does has grown by at least 50 times. The only way we can achieve this is through the industry participation, and of course, in all satellites and launch vehicles, almost all the subsystems are getting realized through the industry support. But what is not done till now is end-to-end the integration and testing of the satellites at an industry premises. So far, it has not been done. All other companies, startups who are trying to do are doing actually very small satellites, which do not have the complexity and the requirements of larger satellites. Even though the SpaDeX satellites are the 200 kilogram satellite, still this size satellite nobody has built in the industry in India. So if we have a hope that in future industry will take some burden of ISRO and start building the large number of satellites that are required for our nation building to meet the requirements of the nation, we need to give them some practice missions. So simply asking the industry, you make yourself capable of doing it, is not going to yield any result. So we determined that henceforth we should try as much as possible to get this integration and testing done at industry premises wherever it is possible. So with the blessing of Chairman ISRO, we took up this activity, and Mrs. Anand Technology came out flying colors at the end of this effort. They, in fact, after the satellites were moved back to URSC also, they continue to work along with our engineers and the technicians to complete the remaining activity at URSC before we shift the spacecraft to SDSC. So I would say this is the industry doing the integration and testing is as important to us as doing the docking itself.
So one small step for UR Satellite Center and one big, bold Hanuman leap for India to trust the industry. Is that a fair assessment?
We hope that it turns out like that. Yes.
No, certainly. And Mr. Rao at Anand Technologies is a ISRO homebred person who has mastered space technology for India and was hoping to get India off the ground. And Atmanirbhar is both URSC and Anand Technologies motto. So I sincerely look forward to a great mission. Now, once you dock, will you be doing an undocking also in space?
Yes. After the two spacecraft get docked, we have also included as part of this mission a power transfer mechanism, which is going to allow one satellite to transfer its power to the other satellite. This is another technology demonstration for a future in-orbit servicing of the spacecraft, including the Bhartiya Docking Station. This kind of missions are also for other remote sensing or communication satellites also. If everything else works and if there is only a power system failure, a small satellite with the required power resources can get docked and give additional life for that satellite. So we are going to demonstrate that power transfer mechanism, which is also indigenously developed at the URL Satellite Center. This will be done. After this, we will be controlling the composite satellite, that is the docked two satellites, as if it is a single satellite with the control system of one of the satellites. This is also a requirement for future in-orbit servicing requirements. After this, the two satellites will be undocked and made to separate, give some decent gap between the two satellites so that they can work independently on their own with their own payloads.
So one experiment and many results expected from that. The usual, the way ISRO does to try and get more out of less.
Yeah, we have to get, because we are using the money of the people. We are using public fund. We have to make the maximum out of that and gain as much as possible from the public money what we are spending. So we try to do our best with available funding.
And will you be doing a single docking, undocking, or if you have fuel, will you be attempting another docking, undocking in space?
It is possible we may do more than once. So at the moment we are concentrating on the first successful docking. We have some plans. What else can be done after the docking is successful? But I would speak about that after we are successful in the first attempt.
I sincerely hope, and India hopes you will succeed. This is a docking, undocking in a circular orbit, if I'm not wrong. The more
Yes.
challenging part is to try and do it in an elliptical orbit. Will that be in the next mission, or is that like the Hop experiment sitting in the backdrop for you?
Actually, we need that kind of capability to achieve the Chandrayaan 4 mission. As you rightly pointed out, docking in a circular orbit is different from docking in an elliptical orbit, because the mathematical solution is time invariant in a circular orbit, whereas in an elliptical orbit, every instant the solution is different. So the computations required on board the satellite is more difficult and it is more stringent. Chandrayaan 4 requires this docking in the elliptical orbit. This is also one of the requirement for us, that we need to do another demonstration mission. We are waiting for this mission to get completed before we can look for the next mission, where we can demonstrate before Chandrayaan 4 the elliptic orbit. But it would not be possible to do that with SpaDeX alone, because we have a very small spacecraft with only 5 kilograms of fuel. With this fuel, it is not possible to change the orbit of the any of the satellite to any significant elliptic orbit. It is not possible to do. That's why it will not be possible to do an elliptic docking with this mission. But we do have these thoughts in our mind. Once this is successful, we will be taking up the other things.
And do you think the standard we have developed for docking could become the standard and on a larger ports for the Bhartiya Antariksh Station, or will we have to go to the American standard or the international docking standard, the way they use on the International Space Station?
See, the international docking standards specifies the peripheral dimensions and the internal dimensions. How it is to be achieved is not specified by the docking standard. So, for us to make our Bhartiya Antariksh Station as well as other human spaceflight missions interoperable with any international missions, it is essential that our docking system has at least the physical dimensions identical to the IDSS. That is an essential requirement, because we cannot tell all our missions only our own vehicles have to come and dock, our own missions only can come and dock, which is not a good strategy for us. So we are developing in IDSS equivalent docking mechanism, which we are planning to call it as a BDS, the Bharatiya Docking Standard, which we will develop, and there are test protocols as defined by the NASA. We will try to get these tests done on the new system that we are developing now under the Bhartiya Antariksh Station program. So that will happen over a period of time. It will be done. It will be called not as the IDS. It is IDS compatible BDS.
Wonderful. I look forward to a BDS, a Bhartiya Docking System standard, and hopefully someday our own crew module can then go and dock to the future International Space Station, because by the time the current International Space Station may be retired, and who knows, we may also be an equal partner in the next effort alongside with our own space station, and we need our own technology. Uh, Anything else we need to know on the SpaDeX mission, sir? How many people were involved in creation of this SpaDeX mission, sir?
See, any ISRO mission, though the project identified people will be of the order of some 150 people, but there are contributions from thousands of people, both within ISRO as well as outside. It will be unfair for me to tell that only these 150 people only realize. No, it is not true. There are at least about 1,000 people within ISRO and another couple of thousand outside ISRO who are contributing to every one of our missions. So it is a collective effort of so many people. We are some of us who are standing up in front are just representing the so many thousands of people. Nothing. It is not the work of few people or this one center or not just even only ISRO. It is the effort of so many people.
If the launch is successful, in how many days can we expect to have the first docking?
Uh, in less than 2 weeks, the docking will be done.
So you'll have to probably stabilize the system, test it, and then attempt it.
Yeah, because we have developed a large number of new sensors. So we need to characterize each one of the sensor before we attempt docking. This is one requirement. Second one is that this mission is put in an inclined orbit of 55 degrees, which means the sun orientation with respect to the satellite will keep changing every day. Because of that, we only have a short window of about 15 days where the sun orientation is favorable for power generation in the docking orientation, and that 15 days window will come again after about 66 days. So the first window for our docking will happen about 5 days from the launch. Say around 4th January, the docking window will start, and we have about 15 days from that to complete the docking. But we do hope that we will be able to complete it in less than 10 days from the docking window start. So the requirement is that the sun illumination condition should become favorable. That we expect to happen around 4th or 5th of January. And after that, we have to go to the docking orientation and test all the sensors and then go for the docking. So about 10 to 12 days from launch is what we are today thinking.
Are you anxious? Are you tense? Docking is something which is very new for India.
I'm not tense because we have done sufficiently large amount of testing for these two spacecraft. Various hardware and software test beds have been created, and our people have been working on this for quite some time now. And particularly last 3-4 years, uh, a dedicated set of people are working on this almost round the clock. So I'm sure that we have done what is possible to be done. Whatever we could anticipate it, we could anticipate all of them. We have done it, but still, always there are room for surprises. But as a leader of my team, I cannot exhibit any nervousness or fear or worries. I have to make my team to feel confident. So they have to derive confidence from me. That's why even though inside I may have so many feelings, I cannot afford to show.
I know on Chandrayaan 3, you told me how you felt, and then finally when it succeeded, you were so happy. I remember that distinctly. Now we have two satellites in orbit, dock, undock. What do we do with them after they are still up in orbit?
Between the two satellites, there are three payloads are there, which are not connected with the docking. They are independent payloads. The what we call as the target spacecraft has two payloads, a hyperspectral camera and a radiation monitor payload. And the chaser satellite has a high resolution camera. So after the docking is successful and after we complete all other possible experiments related to the docking and other mission related activities, we will make use of these payloads and start mapping the earth as well as the radiation environment.
So, like I started off by saying, one mission, many objectives, and use of resources optimally. Fair, sir?
Yes, sir, that is what we wish and that is what we hope that we are doing efficiently.
Always a pleasure talking to you, Dr. Sankaran. You and your team at URSC and at ISRO make India proud. You give us innovative solutions. You give us long-term aspirations. You also give us opportunity to fulfill our dreams. ISRO has always made India proud, and we sincerely hope that this time the docking, undocking, and the use of the satellites will also go well. We wish you luck, and thanks a lot for speaking to me, Dr. Sankaran. Always a pleasure talking to you.
Thank you very much, sir. My pleasure. It is like paying someone for having a feast. That is what we are all feeling. That the feast is the highly complex and challenging, intellectually stimulating technology work. And by the way, we are also getting paid salaries. Thank you.
Lovely. What can be better than to do your work and enjoy it? This was a small discussion about the very complex mission India is going to undertake, which is the docking, undocking of a satellite in space. Only three countries have mastered this earlier. If it were easy, other countries would also have done it. India is mastering a new way of docking, and hopefully, the Bhartiya docking standard and the Bhartiya docking port may become the global standard. In New Delhi, Pallav Bagla for NDTV.